Hey class, this is 17.2 examples, and these are examples of how to find the median, standard deviation, and quartiles if you are given two values that are equidistant from the center. So here's the first one. It says, consider the given normal distribution, the points P and P prime, they call it when you have a little apostrophe above it, a prime. There are 2 points on the curve. Find the median and the standard deviation and the first and third quartiles. So when we're given if these are where the inflection points are happening, then that means that that is one standard deviation above the mean, and this is one standard deviation below the mean. So they're equidistant. You can kind of see that from the mean, right? So to find, what I first need to do is I need to find the number right in middle, because that's the median or the mean is right in middle. Usually in typical statistics classes, the mu symbol is reserved for the mean, but because they're spell-shaped in this particular situation, we can also label it the median as well. But anyways, so how do I find the median? Well, the median's right in the middle of those two numbers. So I can find the average of those two numbers, and it'll give me the number right in the middle of those two numbers. I also could have subtracted the numbers to find the distance between the two numbers, and then divided that distance by 2, and then added that distance to the smaller value to find out what the median. That would have been a different route to take. But I'm going to go with finding the average, because it's a fast way to do it. So when I take the average of two numbers, I add them together and then divide by the number of numbers that I'm adding, just to review that. So that's 144 divided by 2, that's 72. So 72 is my median. And let's just double check, is it truly in the center of 77 and 76? So if to go from 72 up to 77, I would have had to add 5. And then if I go from 72 down to 67, 72 minus 67, that's 12 minus 7 is 5. So that's also 5. So you see that we're a distance of 5 away from both the 77 and the 67. So this is truly in the middle of those two numbers. And the distance from the mean to the 77, we can calculate that by doing 77 minus 72. That will tell us the standard deviation, because this point was this 77, where the inflection point occurred, must be at one standard deviation above the mean. So if I take 77 minus 72, that gives me what the standard deviation is, and it's 5. Okay, then do the first quartile. The first quartile, also Q with a subscript of 1, is the mean minus 0.675 times the standard deviation. So now I plug in what I know to be my mean, that's 72, or median, minus 0.75 times by the standard deviation, which is 5. We follow order of operations here. So I do this 0.675 times 5. That is first 3.375. And then now we do 72 minus that number. So 72 minus 3.375, and that gives me 75.375. And there we go. So that is my first quartile. Oh, wait. Oh, I'm sorry, 68. I added. I was looking at Q3. 68.6 0.25. Okay. And then the third quartile is very similar, but we take the mean and add that same 0.0675 times the standard deviation. So I plug in what I know the mean in this problem is 72 and 0.75 times, and we know the standard deviation is 5. So that's 72, and I already did that calculation of what 0.675 times 5 is. That was 3.375. So if we add those together, we're going to get our third quartile, which is 75.375. All right. Do make sure to follow the order of operations. You know, when a letter or a Greek symbol in this case is next to a number. Recall from algebra that when a Greek symbol or a letter is next to a number, that means a multiplication between those two. So I knew, and make sure when you substitute something in, you put it in parentheses so you know that, and you mean that this is 5 times by 0.75. And then once we had this subtraction, 72 minus 0.675 times 5, I knew that PEMDAS, please excuse my dear Aunt Sally, tells us that we have to do the multiplication here first before we do the subtraction. Because if we subtracted 72 minus 0.76 and then multiplied that whole answer by 5, then we would have gotten a different answer. So make sure to follow the order of operations there. And also notice how I'm writing it. I'm being very detail oriented, and I'm writing the original formula because I don't want to just do it from memory because I might forget it. So I rewrite the original formula and I replace each letter with the correct number. And then I simplify using order operations from there. And I'm writing, you know, the answer. So I did like 0.675 times 5, and I got an answer, and I rewrote that right below where it had that multiplication, you know, and I rewrote the plus sign, I rewrote the 72. So I'm rewriting a lot so that I'm keeping each step organized. And that way you're not having to keep track of things in your mind. And staying organized, I feel like, is half of math. So if you can just stay organized and write all the steps out, you could probably have a way better chance of getting the correct answer in the end. Okay. Consider the given normal distribution. Assume the two labeled values are equidistant from the mean. Find the mean and the standard deviation of the distribution. So, and they give us a hint here that 95% of the data is in this blue region. And if we look back, 95% of the data is within 2 standard deviations of the mean. So that means that these must be 2 standard deviations above the mean. So like this one must be equal to the mean plus 2 standard deviations. And this one is equal to the mean minus 2 standard deviations. So that tells me that I can draw a line here and I can draw a line here. There's actually, well, and this is the mean in the middle, there's a standard deviation here, a standard deviation here, one here, and one here. So there's actually 4 standard deviations because there's 2 above the mean and 2 below the mean. So what I can do to find the standard deviation, we'll see later, well, I guess, is to subtract, I guess since I'm on this, I can subtract 95.6. I'm sorry, I can subtract 86.4 from 95.6, and I can find the distance. That would give me the distance between the 2 points, and then I can divide that by 4 to find the standard deviation. So let's do that. So I subtract the larger number, 95.6, minus the smaller number, 86.4. And I get 9.2. And then I take that and divide by 4 because I noticed that that's how many standard deviations are going to be in that region. And I get 2.3. So that is my standard deviation, 2.3. Now, one way again to get I'm going to do the same method I did above to get the median. It's right in the middle of these two values. So what I'm going to do is I'm just going to add them together. And I'm going to take the average of them. I add them together and divide by the number of numbers to find the number right in the middle of those two numbers. So 86.4. So over here, I'm finding the median by averaging those numbers because they're equidistant from the middle. So 86.4 plus 95.6, 86.4 plus 95.6, and then dividing by 2. So you got to make sure to add the numbers in the numerator first, get one answer here, and then take it and divide by 2, which my final answer, I got 91. So there we go. There's the mean and standard